Hi, my name is Madeleine McGowen, and today I will be giving my historical engineering presentation. So, alright, the first thing that we'll be looking at is the very first seismoscope. It was invented in 132 AD by Zheng King in China. King was an imperial historian and a royal astronomer. In China, there has been records of definitely a lot of earthquakes, so this would be a very useful device. Its name in Chinese literally translates to an instrument for moving the wind, for measuring the wind in the movement of the earth. So it has a 6-foot diameter and made out of bronze. The original was lost, so we don't know exactly what it is. But we definitely have some ideas. There was a couple different theories about the internal method. Either that it was a free hanging pendulum or a thin stick. But in either case, when there was a tremor, it would hit the dragon with the ball in its mouth and drop into the fog at the bottom, indicating which direction the earthquake came. It took place during the Han Dynasty, and there's actually records of 6 years after it was made, detecting an earthquake that was 1,000 miles away. It was very useful, and that's something that really appealed to me about this. How so far back they created the very first device to detect earthquakes. I think that's very interesting. So they didn't call it a mechanical engineer back then, but I would definitely assume that that would be the type of engineering going into something like this. The next thing we have is the Ely Cathedral. The Ely Cathedral was built in Cambridgeshire, England, from 1083 to 1189. So that's about 106 years. A long project. It was constructed from stone that was purchased for 8,000 fields a year and then transported by river. And there's definitely also a lot of marble and local limestone used in the process as well. To your right, you can see this beautiful arch dome shape with an octagon at the center. This was actually added a little bit late, but the rest of it was all created within those 106 years. It was built in cruciform, which means that it was a cross shape. So if you were to get a top view of it, it would look like a cross. It was built by Abbot Simeon, and today it's estimated that it would cost 10 million to build. Cathedrals were constructed by master builders and masons, and today we would call them civil engineers for sure. There was so much that had to go into creating these arches to line up so perfectly. That's something that really appealed to me. Since it was built over such a long time, you had a lot of things taking place during that time of history. You had William the Conqueror, he was enrolled when they first started building. Then you had William II, then you had Henry the First, then you had Stephen, and then you had Henry the II. So there was so much change that happened throughout the building of this cathedral. All right, the next one we have is the Palace of Versailles. Absolutely beautiful. It was constructed between 1661 and 1710 in France. It was built by many of the renowned architects of the day, and it was made out of the finest materials. It had a lot of red brick, white stone, gray slates, and lots of gold decoration. It was actually originally a hunting lodge, but over the years it kept getting built onto until it decided to be made into the beautiful palace. Its most famous room is probably the Hall of Mirrors, which is 230 feet long, with 17 mirrors facing 17 windows, creating a beautiful effect inside. If we were to build this today, it would cost about 2 billion. Quite extravagant. I love all the details they have just in every part of the palace. Just the craftsmanship is amazing. Definitely civil engineering involved for that one. The next thing we have is the very first power line. So this took place was um, built during the Industrial Revolution, where we started to really see a lot of different um, devices kind of like this. But this was the first device automated um, to automate weaving. It was designed by Edmund Cartwright in 1785. He was an English clergyman and investor. He was inspired by the cotton spinning wheel and decided to make a automated weaving device. The loom operated on automation and mechanical power, using a system of gears and pulleys connected to a steam engine. It can replace about 30 separate looms operated by him. This was definitely a big undergoing for Edmund, and he invested about £30,000 into the creation of this power loom. He had a lot of fails, but he kept at it. That's something that really stuck out to me about this, that he kept at it and he was able to put his idea into practice. And by 1850, there were 260,000 power looms operating in England. So Edmund wasn't exactly an engineer, but he definitely used mechanical engineering in creating this device. Next, we have the first helicopter, also known as the VS-300. So on September 14, 1939, Igor Sikorsky made his first flight in his prototype helicopter in Stratton, Connecticut. Igor graduated from the Mechanical Engineering College of Polytechnic Institution in Kiev, Ukraine. The VS-300 weighed about 1,300 pounds, and it had three main blades, and those spun clockwise at 255 rotations per minute, and then one counterclockwise blade that we see in the picture on the back, and that would spin the opposite direction, creating lift. And the interesting thing is, the helicopter was able to go up and down and side to side, where the airplane was not able to do this. So this was a very interesting design. Igor spent about 100,000 over the course of his creating this. And after 102 hours, 32 minutes, and 2 seconds, the VS-300 was donated to the Henry Ford Museum in Michigan. So Igor went to school to be a mechanical engineer, and that's definitely what he used in designing it. Thought it was very interesting how this was able to take flight. So I thought that really appealed to me. The next thing that we have is the International Space Station. This is quite a feat. It was initially constructed between 1889 and 2011, and it now weighs almost 400 tons. And as of today, the cost of the ISS is $150 billion, arguably one of the most expensive things that ever built. It orbits 250 miles above the Earth's surface at a 17,500 miles per hour. So quite fast. It orbits around Earth about 15.5 times each day, which is crazy. So for the astronauts in there, they get a sunrise or a sunset about every 92 minutes. Mainly constructed of steel, aluminum alloy, titanium, and copper. And the solar panels that you see on the side generate between 84 and 120 kilowatts of electricity. Sure, there was definitely a lot of aerospace engineering going into this. This is the last slide of my presentation. Here I have some of the sources that I used.